Hello everyone, in today's video we are going to learn how to compute the relative strength index of stock prices in Python. As always, I have created a post that nicely summarizes everything that I will explain in this video, and you can find a link to this post in the description below. As you will see at the end of this video, my code will produce the identical RSI results to the results that are available on various financial websites, such as this one, for example, Seeking Alpha. So before I start, I have to mention the following. While preparing this video and the post, I realized that there are many websites that provide incomplete information on how the RSI parameter is calculated. Furthermore, there are many websites that use inaccurate methods to compute this important indicator. Consequently, I had to consult the original work of Mr. Wilder, in which the RSI is defined. The name of the book is New Concepts in Technical Trading Systems, and you can access it on Amazon. It's a very nice book, and it's published in 1978. However, it's still actual, and this parameter actually stood the test of time. Now, on the other hand, the Wikipedia page of Mr. Wilder says that he has a mechanical engineering background, which is very interesting for me. And it does not come as a surprise, since from my personal experience, I know that mechanical engineers can apply their knowledge and developed intuition to various real-life problems. Okay, so let us see how the RSI parameter is being calculated according to the original source. First of all, we compute the price differences. In the second step, we compute the initial values of the averages, and I'm going to define the averages in the sequel. And in the third final step, we recursively update the averages. Okay, so let's see how the steps 1 and 2 are performed. So in order to explain you the computations, I constructed this toy example that you can see over here. The first row is the row representing the dates. I simply represented the dates as numbers 1, 2, 3, 4, 5. However, in your application, this will be, for example, January 1st, January 2nd, etc. And the second row represents the prices. So the price at day 1 is 3, at day 2 is -2, etc. And the third row represents the differences. So let's compute the differences. So for the first day, the difference is undefined. So you're going to get NA, not applicable or not a number. The difference in price between the second and the first day is obviously -2, -3, that's equal to -5. The difference in price between the third and the second day is 5 minus -2, that's 7. The difference in price between the fourth and the third day is 1 minus 5, that's basically -4. And the difference in price between the fifth day and the fourth day is 0 minus 1, so it's -1. The next step is to compute two additional variables. These variables are delta x plus and delta x minus. So how is delta x plus defined? Well, it's defined on the basis of the differences. If the differences are negative, then the corresponding value of delta x plus will be 0. If the difference is positive, then delta x plus will be equal to the difference. Similarly, delta x minus is defined as follows. If the difference is negative, then delta x minus is equal to the absolute value of the difference. If the difference is positive, then the corresponding value of delta x minus will be equal to 0. So let us apply this recipe. Since the difference is NA, both delta x plus and delta x minus will be equal to NA. Here the difference is negative. That means that delta x plus will be equal to 0, and delta x minus will be equal to absolute value of the negative differences, that is, it will be equal to 5. Here delta x plus is equal to 7, since the difference is positive, and since the difference is positive, delta x minus will be equal to 0. Similarly, here delta x plus will be equal to 0 and delta x minus will be equal to 4. And minus 1 difference will correspond to delta x plus 0 and delta x minus equal to 1. The next step is to compute the average of delta x plus and delta x minus. However, to compute the averages, we need to choose the appropriate value of the averaging parameter. And in my case, I'm going to choose n equal to 3, n corresponds to the number of samples that are being averaged. However, in practice, it is often the case that n is equal to 14 days or equal to 28 days. So, we are computing the average of delta x plus and delta x minus. So the averages will be computed as follows. Delta x plus average will be equal 0 plus 7 plus 0 over 3. Similarly, delta x minus will be computed as 5 plus 0 plus 4 over 3. And this gives delta x plus average of 7 over 3 and delta x minus equal to 9 over 3. Once we have computed the values of delta x average and delta x minus average, we can place these values in appropriate columns. So we're going to place them in the column 4 corresponding to the 4th date, and we're going to place delta x plus over here. We're going to write 7 over 3 and delta x minus average over here, 9 over 3. The next step is to compute the value of the RSI index. So the RSI index is simply computed as 100 minus 100 over 1 plus delta x plus average over delta x minus average. After substituting the values of 7 over 3 and 9 over 3 in this formula over here, we obtain the RSI value of 43.7. And we're going to write down this value in the corresponding row and the column. So the column be the column 4 and the row will be RSI row. So we're going to write here 43.7. We have now completed the steps 1 and 2. That is, we have computed the differences and we have computed the initial values of the averages and of the RSI index. The next step is to recursively update the values of average of delta x plus and the values of delta x minus in order to compute the RSI index for the date 5. To do so, we are going to use the following formula. Delta x plus average at the current time instant is equal to n minus 1 over n times delta x plus previous. When I say previous, I mean the previous date, plus 1 over n times delta x plus, but not average, at the current time step. Similarly, delta x minus average current is equal to n minus 1 over n multiplying delta x minus previous plus 1 over n delta x minus current. Okay, so let us see what is current, what is previous. In our case, the current is 5, previous is 4. That is, the current date is 5 and the previous date is 4. So, by substituting the values, we obtain n is equal to 3, so we have 3 minus 1 over 3, that's 2 over 3, multiplying delta x previous plus, so this is the previous average, multiplying 7 over 3 plus 1 over 3 multiplying delta x plus current, and the current value of delta x plus is equal to 0. So we obtain here 14 over 9. And this value is placed over here. So we place here 14 over 9. Similarly, for delta x minus current, we obtain 2 over 3 multiplying 9 over 3 plus 1 over 3 multiplying delta x minus current, and delta x minus current is equal to 1. So we have 18 over 9 plus 1 over 3, that's basically 9, 18 plus 3, that's basically 21 over 9. And this value is being placed over here, or should be placed over here. Once we have computed delta x plus current average and delta x minus current average, we can compute the RSI index. So the RSI current is 100 minus 100 over 1 plus delta x plus current average over delta x minus average current, and this gives 40. And we are going to place the 40 value over here. Okay, so this procedure is being recursively repeated. For example, if the date is 6th date, in order to compute all the values corresponding to the 6th date, we would first need to update the differences. Then we will recursively compute the value of the delta x plus average on the basis of the previous value and using this formula. Similarly, we compute the average delta x minus from the previous value and using the formula given over here. And finally, we are going to use this formula to update the RSI current. And this procedure is repeated for the future steps. The previously explained procedure is nicely summarized in the post that I wrote. So this is the first step, compute the price differences. In the second step, compute the initial values for the RSI recursions, and these steps are explained over here. And finally, I explain the third step and I explain the recursive formula. So if you don't have time to watch this video, you can simply jump onto the post and you can read it in order to have some basic understandings of the procedure. Okay, so in the sequel, I will briefly explain the code I wrote for computing the RSI parameter. The first step, of course, is to clear the workspace. And the next step is to clear the screen. As you can observe, I'm using the Spider Python environments. Why I'm using this environment? Well, this environment is very easy for debugging the code and somehow it reminds me of MATLAB. So let's first import the standard libraries, pandas, numpy, plotting library, and pandas data reader for importing the stock data. The next step is to define the period. I'm going to use the period of 14, and that's the standard value that usually traders do to define the RSI parameter. The next step is to define the start date and end date for downloading the stock data. So I'll be looking into the stock histories from 2019 until 2021, and here are the dates. And I will be looking into the SPY index, which is basically an ETF giving you an average of the whole market. Once I have defined the stock symbol, I can simply download the data. As a side note, here you can place any symbol that you like. For example, Boeing should be BA, Microsoft, you can search it online for the symbol, or Verizon, or Visa, or MasterCard, whatever you like, whatever you're interested in. And here with these code lines, I'm going to download the data. Here's my data. I can type data.head to see the first few rows. I have the high, low prices, then I have the volume, and I have adjusted close. This is the adjusted closing price. If I want to see all the columns, I will type simply data.columns. So you have the highest price during the trading day, the lowest price, the open price, the closing price, the volume, and the adjusted close. It's always a good idea to inspect the data by plotting the data. And here I'm going to isolate the closing price. So with this code line, I'm simply going to select one of the columns that's called close, the closing price. And now my closing price will be stored in this variable. The first column corresponds to dates and the second column corresponds to prices. With this code line, I'm going to compute the differences. Now I have the differences, which is my first row. Okay, the first difference is undefined and these differences are differences in prices. Then I can isolate the differences as a list or as an array, whatever you prefer. And here what I'm going to do, I'm going to define positive differences, negative differences. These are basically the delta x pluses, delta x minuses in my previous explanation. Then I'm going to define the current average positive. This will correspond to delta x plus with a bar. These are the averages, and these are the current average negatives. They're going to correspond to delta x minus average. And here I'm going to define a price index that will be my iterator. And finally, I'm going to define a list, an empty list that will store the RSI values. And now what I'm doing here, I'm only iterating through the values stored in the differences, in the different prices. However, I start from the first basically date, since actually from the second date, since the Python counts the first date as a 0 index. So I need to start from the second one that corresponds to the number 1, and I'm going to iterate over the price differences. So if the price difference is positive, I'm going to assign the value delta x plus, simply as differences. If the difference is positive, the negative difference should be 0, that is delta x minus should be equal to 0. And similarly, if the difference is 0, I'm going to assign negative differences as positive differences, and if the difference is equal to 0, both of negative and positive differences should be equal to 0. Now, this block is used to basically initialize the values. That is, I'm going over the price values and over basically the first n steps, right? I want to compute the initial values, and here I'm basically iterating until my price index that's being updated at the end of this loop reaches the period RSI. When I reach this period RSI, or better to say period RSI minus 1, this is the last time I'm going to execute this piece of code from here to here. After that, everything's being initialized. And for the future time steps, for the time steps that are larger than period RSI, I'm going to simply recursively update my average positives, and I'm going to keep on repeating this procedure for all the prices, or actually the price differences stored in this variable. Of course, I need some safeguards. These safeguards is basically the situation that we want to avoid is when we divide something by 0, that's going to crash our program. And I'm going over this code, I'm just going over until I reach the last price difference. Once I do that, I will create the RSI time series. So I'm going to construct the RSI series from the computed RSI values, and I'm going to assign the index that will correspond to the date that's equal to the period RSI plus 1. Here you should be careful how Python index the variables. And finally, I'm going to basically define the 30 and 70% limits for the RSI index. These limits are used basically by traders to identify oversold and overbought stocks, and I'm not going to explain this in this video since it will take me an additional hour to explain the trading strategies. And finally, here I'm going to create the pandas data frame corresponding to these limits, and at the end I'm going to plot everything on two graphs. So let's see how this code works. I'm going to execute everything again, and this code will produce us the values. So you can see clearly the SPY index. This is Corona situation happened here. You can clearly tell that RSI index fell to almost 20, right? And this was a very good place to buy stocks. Who purchased here probably made several millions by now, or billions if you're a hedge fund. Now, let us verify that my code is accurate, that I have accurately implemented all the formulas. So what I'm going to do, I'm going to compare my results with the results available online. Okay, so for the date 2021, 2nd, or actually 3rd of February, I get the value of 56.60, let's say 9. Let's see what do we have online. So I'm going to go on the website Seeking Alpha, and I'm going to look for the basically RSI index of SPY. So what you can see here, this is the stock price, the first row, and the second row, the second actually row graph corresponds to the RSI values. So let's see, February 3rd, the RSI value is 56.69. You can see the value basically in this corner over here. So watch this indicator over here again. Okay, so what can we see? 56.69. Let's go back to our code. I'm getting 56.69. Very good. Let's look it up for 10th, or actually October 28th. The value is 35.45. October 28th. So let's see the October 28th. October 28th. So the value is, look at the value over here. is 35.45. And I'm getting 35.45. Excellent. So far, so good. Let's do the third test. So I'm getting 82.21 for the date of September 2nd. Let's see what Seeking Alpha is giving us. 82.21. Let's just remember the date. The date is September 2nd. September 2nd. September 2nd. We are getting 82.22. This is what Seeking Alpha is giving us. And I'm getting 82.22. Very good. So I did actually accurately implement the RSI formula, and my results match the results available online. Now, if you select over here date that's basically very close to the 2021, let's say you take 2 months in the past and you take the RSI index of 14, your results will not match the online data. You'll have some errors, maybe a few percent, because the catch is that you're initializing the values using relatively recent dates. So you need to look a little bit more in the past such that you can properly initialize all the values, because online, I don't know how their algorithm works, but the formula is equivalent. However, they have probably computed the initial values maybe 10 years ago or etc. Okay, I hope that you like this video. If you like this particular video, please subscribe or support my channel. Thank you very much and have a nice day.